The first thing I want you to do is look at the top of page 68 in your workbook. Okay? Don't tear your page out. Mine just fell out because I use this page a lot. I refer back to it a lot. And it fell out. Probably not by itself. It probably had help, but you know. Okay? We're going to refer back to this page a lot when we're talking about equations with the vertex at HK. Notice it says that up there, vertex at HK. Okay? So you need to make sure to notice that. Maybe highlight that or something. Okay? Notice that there's two kinds of axis of symmetry that we're going to talk about. We're going to talk about a vertical axis of symmetry, which you've talked about since Algebra 1. But we're also going to talk about a horizontal axis of symmetry. You did not talk about these in Algebra 1 because these are not functions. Do you remember how to tell by looking at an equation, by looking at a graph if something's not a function or not? Or if something is a function or not? It's called the vertical line test. How many places is the equation touching my pencil? 2. That means it's not a function. Look at this one up here. How many places does this function touch my pencil? 1 the whole time, so that means it is a function. Okay? Does that make sense? Yes? Okay, good. So we have vertical axis of symmetry and we have horizontal axis of symmetry that we have to deal with. What's the difference in the equation? This is y equals, and it's the h value that's squared. This one's x equals, and it's the y value that's squared. The y is the the k is the vertical change, so it always matches up with the y, right? That's why the k is inside with the y here, and the h is inside the parentheses with the x here. Horizontal change goes with the x. Yes? Okay. So you're going to use these formulas a lot today. The only thing that this paper doesn't tell you that's really super important is what P is. Okay, so I want you to write this in. P is the distance from the vertex to the directrix, or from the vertex to the focus. P is a distance, right? So it's going to be a positive value. P is a distance from the vertex to either the focus or directrix. It's the same distance, so that's why I'm saying either. P is the distance from the vertex to the focus or the directrix. Oh, I'm glad I chose a post-it note color you could read. Sorry about that. Okay? Any questions? Now, talk with me in general real quick. Look at all 4 of these graphs. Look at the focus. It's right here. It's right here. It's right here. And it's right here. Where's the focus in relation to the parabola? Yeah, it's inside the parabola, isn't it? Where's the directrix in relation to the parabola? It's right here. It's right here. It's right here. And it's right here. It's outside. Okay? Now, also I want you to notice that the directrix is a line while the focus is a point. Okay? Algebraically, we know a parabola is formed by taking whatever x value that you get and taking advantage or taking into account what the h is and then squaring it and then dealing with these numbers out here. But algebraically, the shape of the parabola comes from the fact that you're squaring an x value at some point, right? Geometrically, guys, a parabola is formed I'm going to do a horrible job at drawing this because I always do. Sorry. So just use your imagination. Okay? Let's say that's my vertex right there. There's my parabola. Let's say here's my focus. If that's my focus, then my directrix is down here, isn't it? Any point on this parabola, that distance and that distance are the same. See what I'm saying? I always do a horrible job drawing it. Okay? This distance right here is P. This distance right here is P. Every point on the parabola is equidistant from the focus and the directrix. These two are supposed to be the same length, is what I'm trying to say, yes? Geometrically, that's how a parabola is formed. So keep that in mind when you're going through some of this work today. Okay? So, as I try to find a piece of paper that used to be right beside me and now it's not because I'm trying to show you it. Oh, jeez. This will work. If I say to you, the focus is at 2, 6, is that enough information to write an equation? No, it's not at all. If I say the focus is at 2, 6, 1, 2, 1, 2, 3, 4, 5, 6, aren't there 4 different parabolas I can draw from this? It could open up, it can open down, it can open right, and it can open left. So I got to know at least one more piece of information. I could know where the vertex is, I could know where the directrix is, I could know the value of P, but even then that doesn't help me because it would only tell me if it was up or down or left or right, right? So I might tell you that the directrix is at y equals negative 6. Well, y equals negative 6 would be right here, right? Where's the vertex of this parabola? Remember, the vertex is the point where it changes direction. If you know here's the focus and here's the vertex, or excuse me, the directrix, doesn't the vertex have to be in the middle? Absolutely. Well, where's in the middle of up 6 and down 6? Right here, isn't it? That's my vertex. My vertex is at 2, 0. Now, does this open up or down or left or right? Doesn't the parabola have to surround the focus? So the focus is inside. So won't it open that way? How technical was I when I just graphed that? Not very at all, right? I just went zhun, zhun. Okay? That's what I'm asking for today. When it asks for a graph, do what I just did. Okay? My concern is not so much you can graph parabolas because we have time for that. Okay? My concern is that you know which direction it opens right now. Okay? What if I ask you to write the equation of this parabola? Could you do that? Well, you know it opens up, so you know you're going to use this one, right? This equation as a pattern. So I'm going to start with y equals 1 over 4 times p. What did we decide what p was? Or could we figure that out? P, remember, is the distance from the focus to the vertex, or the distance from the vertex to the directrix. Thank you. Either way, it's the same, isn't it? So as long as you know it's one or the other, you know they're the same. What's the distance from the vertex to the focus? 6. So 1 over 4 times 6. 24. X minus, well, here's my vertex. Isn't this HK? You remember that? If you don't, it says it right here. The vertex is at HK. So X minus what? H2 squared plus K. Done. Nope. I don't have to solve for anything because all it asks me is for an equation. That, my friends, is an equation. And even if you're not my friends, that's still an equation. Okay? Any questions about that? Go ahead. Uh-huh. When it's y equals, it's going to open up or down. And when it's x equals, it's going to open left or right. It depends on what information you're given. That's not a bad question at all. Okay? It depends on what information you're given. And sometimes you're just given a bunch of points. And if you're a visual person like me, I need to graph it. I need to say, oh, here's my vertex and here's my focus. Guess what direction it opens? Right? Because it's got to surround the focus, remember? Okay?
But I mean, you surround the, well, we have to start with the vertex.
Yeah, I have to start with the vertex.
Could it not be on the other side? Or, no, that's we have our point.
Uh-huh, we have our point. Okay? How did we know this one opened up when they didn't give us a vertex? They only gave us a focus and a directrix. The parabola has to surround the focus, right? It has to open around the focus. Okay? So it's just a matter of looking at it and kind of figuring out, using this chart right here, please refer back to this. This is super helpful. Okay? On some of your problems, they give you an equation and ask you to graph it. Well, we kind of did that right here, didn't we, without them even asking for it? Because we graphed it so we could figure out the stuff. So I don't think you're going to have trouble with that. Write the equation from a graph. Again, I don't think you're going to have trouble with that because we just did it. On page 73 in your workbook, it asks for an equation of the parabola in vertex form. Now, this is kind of vertex form, but remember vertex form is more like y equals a times x minus h squared plus k. Okay? Now, while this 1 over 4 p-value is very similar to a, they're not exactly the same. They do the same things. They change the shape of the parabola, but the value of p and the value of a are not the same. And you know that because they're different letters, right? So just be careful when you get to page 73. Don't try to make it harder than it is. Okay? On page 73, it also asks you to use some standard form stuff. Y equals ax squared plus bx plus c. Look at the notes that are there in your workbook if you have any questions. Or you can also what? Ask me. Oh yeah, ask me. You could ask me. Okay? I do have the answer key pulled up if you want to check as you go. And I'd like to give you the rest of the period to work on this so you can ask questions if you need help. Got it? Any questions?